So page 4, final question on the test, question number 8. Unfortunately, the directions are cut off on the screen here, but I can read them to you. It says, give the best description of the polygon bound by the following equations. Justify your conclusions below. So there's a nice Cartesian coordinate grid that's provided here, and I've kind of scaled it appropriately for this problem. As you look at it, you can see there are 1, 2, 3, 4 equations. A couple of them are actually, I thought they were super simple to graph. Some of you got them backwards, and I kind of understand how that can happen, but I really encourage you to think about that and try and avoid it in the future. The first one I have here is x is 0. I want to graph this one, x is 0, and I also want to graph x equals 4. So I'm going to come over here and let's do the x is 0 first. So the line where x is 0 turns out to be the y-axis, right? Anything I select, let me grab a little bit slightly thicker line. Anything that I select on this line is the line x is 0. So y's are changing, right? Y's were positive, now y's are negative. But all along this line, x's are always equal to 0. And the other line that I have is x is 4. So again, y's are positive, positive y's, positive y's, positive y's are y is 0, now y is negative. But every single where on this line, x is always the number 4, right? Y's were changing, but the x was always 4. You know what? There's pressure sensitivity with this pen, and I think I pressed too hard with this one. Let me try this again. It looks sloppy. All right, so these are our those two lines. Now let's take a look at the other two lines. The other two lines that we have are written in, I guess it's standard form. I'm going to change it to slope-intercept form. I think it'll be easier for me to graph these. So I'm going to take away 3x from both sides, so this becomes 4y equals a negative 3x plus 32. And I'm going to divide both sides by 4 now, I guess. So this is 4 is going to equal negative 3/4 x. And then 32 divided by 4 is, I believe, 8. So plus the number 8. Let's do the same thing with the other equation while we're here. So this would become 8y equals negative 6 times x plus 24. And then I'm going to divide by 8. So y equals negative 6/8 x. And then 24 divided by 8 should be, what is it, 4? No, 3 times 8 is 24. I've done this recently. That's a problem. 3 times 8 is 24. 3 times 8 is 24. This fraction, this slope actually can be reduced, right? This is negative 3/4. And that's a nice observation because I now can see that these two lines are indeed parallel to each other. They both have slope of 3/4. So let's go ahead and sketch the graphs of those. This first one I'm going to start at 8 and go down 3/4, and the other one's going to start at 3 and have the same pattern. So one of them starting at 8. Let me I'll grab a different color for this one. I'll grab this red. Start at 8, and then it's going to go down 1, 2, 3 over 1, 2, 3, 4. Okay. And then starting at 3, I'm going to go down 1, 2, 3 over 1, 2, 3, 4. Great. I should draw the lines that go through those points. Okay, so with those lines in place, to me this is at least a parallelogram because I know that all vertical lines are parallel to to other vertical lines. So the blue lines are parallel, and this is justification because the slopes of the red lines are both equal to negative 3/4. These lines must be parallel also. So at a minimum, it's a parallelogram. The other special thing, well, and there are no right angles here, right? There's no way a vertical line is going to form a right angle with anything other than a horizontal line. So they're not right angles. But the other thing at play is what are the lengths of these sides. So if I look at this side, it's 1, 2, 3, 4, 5 units. So this side is 5. The other one is going from 8 to 3. 8 minus 3 is 5. And I could do that here, right? This one's 5. This is starting at 5, and 5 minus 0 is 5. So they're both 5 units long and parallel. And then as I move along the top, you can see that this forms this right, I can make this little right triangle here that's 4 units long by 3 units long. Well, that's a perfect 3, 4, 5 right triangle, right? 3 squared plus 4 squared is 9 plus 16, which is 25. So the length of this side from here to here is 5 units long, right? Because the square root of that sum, the square root of 25 is 5. So this is 5 units long. And then if you look at the other one, it's got the exact same 4 and same 3. So it's a 3, 4, 5 also. So what I end up with here is a parallelogram, no right angles, but all 4 sides are equal to 5. So the absolute best name for this is a rhombus. So I'm looking at an authentic, genuine rhombus. And again, one of the things that the problem prompt said, it says give the best description of this polygon. So the absolute best description is a rhombus. So that's my classification. I would say this is a rhombus. And my justification is both pairs of opposite sides are parallel. And there's 2 ways that's happening. The blue lines, right, are vertical, and all vertical lines are parallel to each other. And the red lines have slopes that are equal. They're both slopes of -3/4. And the other thing is all the lengths of all the sides are 5 units long. A couple of those sides I could just do a subtraction problem, like for example 8 minus 3 is 5, and the other one's 5 minus 0 is 5. So the left and right hand side are 5 because of subtraction. The ones that are above and below are 5 units long because they're Pythagorean triples. So you can see the 3 squared plus 4 squared is 5 squared, so they're 5 units long. So those 2 justifications together allow us to conclude that we have a genuine rhombus. And that concludes the study team. No, this is the individual test for chapter 7. This is going to be, it's part of a playlist. It's all combined together, and I hope you found this helpful. Remember, 70% of the next test will come from previous tests. So studying this now and looking at problems like these and getting proficient with these kinds of ideas will really help kind of pave the way for doing better in the future. I wish you well. I hope to see you in class with individual questions, and come by at lunch, after school, before school. Happy to talk about math anytime. And again, big deal is if you have a problem that you don't understand, why I deducted points or what's going on, come talk to me, and we can look at some things together that can help square some things away for you. This is Mr. Roberts. Have a good day.